AP99Conf. My name is Garrett Hamlin. I'm a current developer advocate at Airbrake. We're an air performance monitoring company. And my talk today is on improving performance of micro front-end applications through error monitoring. There's a lot of talk around front-end applications and a lot of talk about micro front-ends, and we're going to get into that. But first, a little bit about me is, like I said, my current position is developer advocate at Airbrake.io. I've been a web developer, senior and junior, for the last 8 years, roughly. I've done a lot of front end, I've done a lot of back end. But before that, in a previous life, I was a competitive ballroom dancer with my lovely wife. We have 2 kids. I've taught everything from technology to dance. I'm an avid rock climber, father of 2, and I'm a tinker. I love to 3D print things all the time. So let's get into it. In order to understand error monitoring and some of the things that are going to come up from that and how it applies to latency and applies to, that performance that we all love, we're going to talk a little bit about where we came from. So we're going to talk a little bit about the evolution of web applications and get into some of the problems and issues that we ran into along the way and some of the problems that we're running into now with micro front-end architectures and applications and what kind of latency they cause, some things that have gone wrong in the past and how we can ultimately mitigate those through application monitoring, specifically error monitoring. So at the beginning, there was Web 1.0, right? Back in 1992, we have 92, 93, we have essentially what's we consider as the Big Bang. Basic pages, early 90s, a lot of just layout and markup, not really much to see in way of design or in way of usability. It was kind of used a lot for professional papers and laying out basically papers and scientific technologies. Then we get into the early 90s and we start to see a lot of chat rooms, a lot of forums, a lot of bright pinks, oranges, and yellows, and some violent colors. Glad we steered away from that. And in the late 90s, we have the development of JavaScript, right? As everybody's familiar with, it's what we use pretty much every day. Moving through that, we start to see Web 1, or that big bang of the Web 1, where you start to get massive companies, Amazon. I consider Facebook and Google kind of in that realm. You have the browser wars. You have all sorts of things that happen kind of right at the same time. Everybody was making money. We ultimately led to a web application crash. But in those early 2000s, giants are born, right? We start to see things from an application standpoint that are recognizable today, right? We start to see recognizable patterns from desktop application development, where we stole some of those patterns, some of those principles, some of that NVC principles from previous application development and started to implement them into the web. We start to see the foundations of the modern web. In this world, WordPress and PHP are kind of king. You start to see some struggles working with JavaScript, and we get lovely libraries and some actual patterns that we use today coming out of jQuery. You start to get asynchronous JavaScript with Ajax. Some of those massive things start happening, and we really see the web kind of rise and push forward to usable applications. This is where we actually see the development of Facebook, Google applications start to come out. We're able to run fully baked applications in the web. Then 2006 rolls around and we get plot twist. Apple basically hucks us an iPhone and says, good luck with a full-blown browser. So now we have to rethink and refactor and review how we view the web, not only from a scaling standpoint and not only from a reusability standpoint, but also from a viewer and a user interaction standpoint. It's completely different from everything that we've worked with, right? Then we start to see, this is where we start to see Web 2.0. Right, we start to see a growth of recognizable patterns that we know from desktop architecture. We start to see that plot twist start to develop through that mobile technology, and we start to see the screen and user interaction and the way our users use applications from a web standpoint shift more towards mobile. Right, web architecture start to become more complex, and we start to shift into that next era, which is going to be JavaScript libraries and patterns on a larger scale. So then we get Web 2.1, in my opinion, that's what I'm calling it. And it's a framework free-for-all. It seems like every other day there's a new framework. Every other week there's a new framework. And whatever you were using is wrong because it's the newest, latest, and greatest that's cool. You start to see jQuery really spin up and get fairly large. You start to see Angular come out with Angular 1 and all the hassles that come out there. We start to move from where we were at having kind of like a basic MVC architecture where we have HTML handling your markup, CSS handling your design, and JavaScript handling the basic flow of information, to now us deciding that it's an absolute free-for-all, and we go for a single-page application. So no longer are your JavaScript and your HTML separate. They're one and the same. We're just going to go ahead and dump this, use JavaScript to dump things on the page. We're going to use data pulling from here and there and everywhere, and JavaScript becomes absolute king. And we start to see some of these monolithic architectures, these Ember, Backbone, Angular, Ruby on Rails starts to come out in this area. And we start to see these monolithic architectures happen where you may have hundreds of thousands of lines of code in one single application running everything from the back end to the front end. And we start to see a breakdown, right? It's really hard to scale these. It's really hard to go and fix and manage and maintain. We're starting to see some cracks in our beautiful architectures and beautiful frameworks that we've created on the web. And so mindset shifts just a little bit to components, right? So we have these component-based libraries now that are starting to come out, and they're written in various frameworks, and one component works with another component. We can start to pull them together, but they're still in that large monolithic architecture. We start to see patterns develop. React is a huge one here and comes into play, where we start to develop the flux pattern, right? This pattern of listeners and watchers and emitting events on the web like we can on a standard bus or standard operating system for desktop applications. We start to see that it becomes scalable. Data's in different places. It no longer has to just exist on the back end. It can also exist and perpetuate through the front end. We can also manage our own state, and state becomes king. And all of a sudden, out of nowhere, the Internet of Things explodes, right? So we've got these patterns that we've dealt with and that we're comfortable with, and we're in our safe space. We figured out mobile a little bit. We figured out the web, and we're good to go. And then the Internet of Things takes over, and now we have no idea what the web means anymore. The web could mean your refrigerator. The web could mean your car. The web could mean anything at all, from your thermostat to quite literally your children's toy that is keeping an eye on them while you're away, right? And so we start to move towards these progressive web applications, and we start to move into an area that we are completely unfamiliar with, right? All the sites are responsive. Everything works on every screen, no matter what. We start to get these grandiose ideas, but we still have these monolithic architectures. So when you take a step back, we're not in Kansas anymore, right? We've got to reevaluate. We've got to relook at how we do things. And we start to see massive errors and massive latency spikes, because as developers and as creators of this technology, we have no idea what your network is going to be like. On the web, we could. On the web, we could say, hey, we know you're going to be on X internet connection. You're going to have wonderful Wi-Fi. It's going to go straight to your house, or you're going to be on a business, and we're going to have, a T1 line. So I know I can get quick data to you as fast as possible. Mobile through a wrench in the works, where you could be on a 3G network and not get everything that I need you to see. And it'll be harder to work with, but we can back things off. We can optimize. And now I have no idea how we're going to put a website to help you meal plan on a refrigerator, but we have to, right? So moving forward, we start to see some of these cracks and some of these errors start to show up. The next shift we see in the web development world, and moving over towards where we are now and where we are today, is this new idea of microservice, micro-frontend architecture. Micro-frontend architectures, at least introduced to me, the idea came about and started kicking around about 2016, and really kind of have come into their own. A lot of people don't like them. A lot of people love them. They're going to get us into kind of where we're going with application management and application monitoring, specifically error monitoring, because error monitoring is key. You cannot run a modern application without error monitoring. So we're going to talk about 3 different approaches you can go through. The first one we're going to talk about is this component library. Second one is going to be application per page, or what I call application per page. I'm sure there's a better name for it. I'm just, like all developers, terrible at naming things. The last one is federated modules. We're going to talk about this debugging section here. So first off, let's go ahead and talk about your shared library example, right? So the way this essentially works is you've got different pieces and different chunks of a page, or different chunks of multiple pages and multiple applications that we can see kind of working on this library. You have this internal library, and what we've done is we've divided up sections of real estate, if you will, into different land ownership. We're back on the feudalist system, right? So king, project manager, declares, hey, here's what we're going to do. Here's how we're going to do it. Here's who's responsible for it. And he divides up his land into his different lords, right? Team A, you are in charge of header and footer, right? You're going to put things into the internal component library. Those are going to be shared across everybody. Team B, you're going to be the details page. Team C, you're going to handle all my navigation. Now, the downside to this is if anybody changes any piece of their individual application, just like a monolithic architecture, we have to hard stop. We have to hard stop the code. We have to deploy this internal library right here. And we have to redeploy every single application that uses it. We could have multiple teams across multiple different organizations of our company using this internal library. Every time we deploy that, if it was imported in a RubyGem NPM package, pick your poison of whichever way you want to build your web application, we have to have multiple deploys now, and we have to ensure that our communication between these applications and their states, as well as any other application that wants to use them, are working, right? Because if we messed up the communication or the contract between that application component and its overarching application, now your application is going to fail, right? So your testing overhead gets huge. It's also incredibly difficult to debug these, because if one specific component throws an error, we got to be able to drill down into that component, and we have to know which application it came from, right? It could be a state situation where the application was using a weird state, sent it down to the component, and now we have no way to tell, because all we know is there's an error and my page won't work, right? So next up, we have our route per page, or application per page, right? And the best way you can describe this is vertical teams. And the best probably example that I've seen and that I've gotten to work with is the Spotify model, right? So you have, this is an example using an Amazon page, but the idea is similar. We have one team that deals with the search page. We have one team that deals with the product page. If you wanted to apply that to Spotify, that's your new listings, or kind of like your home, right? You have another team that's working on the discovery page. That's all they do. And then the next team is working on the accounts. Underneath this is all of your different playlists, as well as your account settings, all sorts of stuff. They're each individual pages, right? And they run as if they're independent, separate applications. They're deployed independently. The beauty of that is we don't have to stop anybody else. If my team, let's say my team's a search page, if my team is done, we can kick it out the door. We don't have to wait for anybody. We don't have to wait for mom to say yes. We can just handle it, right? We can deploy that as quickly as possible. The way we handle that and the way that we make that work from a web standpoint is we have routing and navigation over the top with something like an edge router. There are a bunch of different applications that do this. There's a bunch of different ways to do this. You can do it in .NET, you can do it in Node, you can do it in whatever you want to do. But we've got this router over the top, and that's what truly binds these things together. Now the problem with that is we have one source of failure, and if we decide, just like in component libraries, if we decide we're going to mess up a contract somewhere, or we're going to call something outside of our domain that lives under a different domain, and we don't call it correctly, let's say an endpoint, and our routing doesn't know about it, the router's going to be the thing that throws the error. And so you're going to see an error, and the router couldn't find the route. It's going to come back. We don't know what happened, and we don't know which actual application may have thrown that error. So it's harder to narrow down, harder to debug, once again, but it allows us to scale very, very quickly. Right. Last one, the radical new child on the scene of the group is called Federated Models. And I'm using a diagram adapted from another gentleman who did a wonderful explanation and has an article on Micro-Frontend. So I'll see if I can get that out to everybody. And I encourage everybody to read it. This is called Federated Models. And like I said, Federated Models, in my mind, came out around 2017, I want to say. I could be wrong on that, but that's when I was introduced to them very first. They came out with Webpack 5, or the idea was talked about, and they officially rolled with Webpack 5. But what this allows us to do is this allows us to build components as if they were their own application and share them across. It overcomes that massive barrier that we have in the application per page architecture on the last slide, which was I can't share any of my components across that. So if I have a header, or I have a footer, or if I have a sign-in, or if I have any sort of component there, I can't share that. So that also means that I have a harder time caching things, right? Which helps reduce our latency. So if I can't cache and I can't share, like on the other page, I run into a massive problem. So this kind of combines the best of both worlds and allows us to create components and run them as if they were their own application, right? So the diagram here in the example here, I think, shows it best. We have an application. Let's say we're going to build our sign-in application. We're going to build that in React, and we're going to build, we're going to say a header or a footer in React. And then we want to move over to Svelte because we really like its ability to go to mobile. And you know what? I want my navigation, my menu bar, to be in that, because that's the best possible option, because then I don't have to worry about scaling or sizing. Then I like the bulk of my application to be in View, just for kicks and giggles, where I would love to be able to see and read my content in a very familiar and friendly way that's not only easy for me to develop, it's also laid out the way the user is going to see it, right? And the only downside to this is, since everything's its own application, we have to manage state. Well, there's a way to manage state as well. There's an app that I've used before called Single Spot, which allows us to create a home app and a state manager. And the way this all works is we create an application, kind of this, you can see the dotted line here, kind of this red dotted line, this home application that is consuming all of the other applications. Those other applications are then delivering to their own pages. The beauty of this is they're actually live and running. They can take data and they can work on their own. I could visit their own URL and actually get that specific component, play with it, and work with it. If I change anything and deploy it, I don't have to redeploy any of the other applications. The home application picks up the change like that, right? It immediately picks up that change because it's bringing in a hosted running app, and it's just allowing it to live on its page. You can run into some cross-site errors, and you can run into some core errors there, but those are easy ways to go around. But here, state is king. State determines what you're doing. However, just like the other two, we run into an issue where if that contract between the application and the component that was running of its own free will and accord, let's take this React application. If somebody changes the contract of how that interacts with the state, now we're going to throw an error. And most would say that it comes out of, that the error would come out of, the specific single spot application. That's not the case, right? Or I'm going to teach you how to mitigate that, right? Once again, fairly difficult to debug. So we've been talking a lot about how applications work and how development works and how product teams work, or how teams can be aligned to be able to develop these microservice front-end architecture. It's a long history lesson, and you thought the topic was on error monitoring? Well, here we go, kids. Let's get into error monitoring. There's trouble in paragraphs. With this microservice front-end, state is the most important part of the applications, and bugs in one component can crash everything else with it. If I have a small application or a button, let's use the smallest one I can possibly think of, which is a button, that crashes the rest of my application, why in the world would I want to use that? Because my downtime and my user experience are terrible. And if we're going to look at this from a performance standpoint, to me, the number one performance metrics, we can talk about, I know we're at P99, we can talk about latency all day long. We can talk about reducing size of packets. We can talk about poor networks. We can talk about making sure we consolidate our data. We can talk about caching all day long. Ultimately, the best performance metric you're going to get is your application usable, and does it do its job in a way that our users are happy with, right? A user is going to tell us one way or the other, your stuff is terrible and I don't want to use it. And they'll move on to somebody who has either a better UI, better latency, better uptime, quick responsiveness, whatever the case may be. That's our number one metric is it usable for everybody for 99% of the web, right? So these application performance and reliability relied mainly on the back end. And it was all static assets, serves, caches, use your CDNs, get as close as you can to the user, all that kind of things. And if there's an error, we hope we fix it, right? Error monitoring solves that. Error monitoring fixes not only our old problems, where we can then take a look and view, actual error logs, but we can actually see which application it came out of. So to get into error monitoring, discuss error monitoring. There's a slew of products out there. You can use a number, right? Error monitoring performance solution. We're going to talk. There's Datadog. Sorry, there's Datadog. There's Airbreak. There's I can come out. I obviously have a biased opinion of which is best. But there are a bunch of solutions out there, and essentially what these do and what they break down to do is when you install them, they are an NPM Ruby gem package, whatever you want to use. You install them as a package, and we're wrapping your components around these error monitoring components. What they're going to do is they're going to catch any error that you have coming out of that component. The coolest part about these modern error monitoring solutions is they provide access to your state. They provide access to your network capabilities. They also provide access to potentially AppDex scores, which is a reliability and a usability score given essentially by the user and a number of metrics. So when we have an error thrown by one of these applications, and I'm going to scroll back to one of these applications, right? We're going to take our fake application. When I have an error, if I use error monitoring, if I actually use the tools available to me and wrap these applications inside of an error, I'll get insight the second that error is thrown, rather than just taking our old route, which was pumping it to the dashboard and saying error, sorry, hope you can figure this out. We can actually drill down into which application, which line of code, specifically which function, and what the state was at the time, giving you accurate context to your errors, allowing you to be able to create faster fixes and deploy fixes faster, as well as cutting down on some of that lead time that you have between reporting of an error and our debug team being able to go through it. It's an absolute nightmare to hear of, hey, your page is broken from one of your users. QA should have caught it, developers should have caught it, DevOps should have caught it. Somebody should have caught it, right? And we can pass and point and play the blame game all day long. But we're going to go through and we're going to talk about real world examples real quick, right? So real world examples. In my career, I've had the opportunity to work at a bunch of different companies. I've worked at anything from digital asset management creation, which was an awesome company where we implemented the first style of component-based architecture, which was we created a library. And that's where I learned everything about what not to do. It's one of the second companies that I worked for is a fintech company, and we ran multiple different applications across multiple different clients, across multiple different networks, none of which were the same, and we couldn't reuse any of the assets. And there I learned the value of reusing assets. But when we had an error, because everything was so isolated, it was relatively easy to find and mitigate, hard to fix. I worked for a real estate company. I've worked for two real estate companies, actually. I've worked for another financial industry company, and those two I learned the value of combining methods to create those microservice architectures. And specifically at one of my favorite companies that I've worked for, we implemented a error monitoring system, right? We used our basic error monitoring system. It was something that Azure offered. I can't remember the name of the actual tool itself, but we implemented error monitoring. And that was my first introduction to error monitoring. At the beginning, when we created that application, we took the approach of doing multiple different applications per page sitting on top of an edge router. And we ran into that problem that I explained earlier, where if we had an application throw an error, we couldn't drill down, right? Because everything came through directly from the edge router. And the edge router would tell us, hey, I have an error, but I can't tell you where it came from, can't tell you where it's going. So as we dug deep past that layer and implemented this error monitoring tool, we were then able to see at least which application, and from there we could narrow it down. And that really lit a fire under me to be able to start using error monitoring. And what we were able to do there is, once we realized what errors we could do, we then were able to start using our error monitoring tool to actually monitor our performance and our time to first paint, those core web vitals. And we were able to start looking into some of the data caching techniques that we were using and some of the state management techniques that we were using. We were able to actually cut down a lot of those times just based on using this error monitoring tool, this application insights, that's what it was, application insight tool, to look into the application and see, okay, it's taking this long to load. We threw these 4 errors. Why are we getting those errors? Those shouldn't be dead endpoints. We actually ended up, I think the third day after we implemented application insights, we found something like 150 error 500s on the back end, which should have never happened. It should have been caught long before then. We had a full QA team. We had developers working on it. We had a full release team with DevOps. But it wasn't until we implemented that error monitoring tool that we really saw a change in how our application ran and how it functioned from a user standpoint. And what it did is it changed my mindset to where we are today. And where I am today is specifically performance of the application and performance of the features that we roll out falls solely on the developer. You can argue with me all day long. And if you want to, feel free to come change my mind. But your application and your responsibility to be able to make sure that your users are getting the best and greatest benefit out of your application that they possibly can is the developer's responsibility. Not QA, not DevOps, it's the developer. And every application and every feature you push, if you want to be able to deploy by yourself, if you want to be able to deploy and be comfortable and confident in what you're doing, my suggestion, implement an error monitoring tool. If you need help convincing a boss or a project manager, hit me up. I'm great at it. It's kind of my job. But the ability to be able to ensure that your users are getting the best possible experience out of your application is to be able to implement error monitoring. I don't care how you do it. I don't care which tool you use. Obviously, like I said, I'm a little biased. But make sure you're using it, because we live in a world now where we have no idea where the web is going. Web3 is completely new to me, and I'm excited to look into it. But we have no idea where we're going to be in 10 years. But the one thing we do know is no code is perfect, right? And no application runs smooth 100% of the time. If it did, half of us would be out of a job. So why don't we prepare ourselves for the future? Steer into the skid on these microservice architectures and set up our error monitoring now inside those applications to prevent any of the issues that we've had in the past from happening again. Thank you for your time. Once again, my name is Garrett. Feel free to hit me up. I'm on LinkedIn. I'm on Twitter. The handle should be somewhere on, I believe, my first slide. But feel free to reach out. Love to hear from you. Thanks.